Non-residential HERS verification. The material in this training was taken from two reference sources. The first is the Non-Residential Compliance Manual. It can be found at the Energy Commission's website at the link listed below. And the second is the Residential Reference Appendices, sections NA1 and NA2, which is the Non-Residential Appendices 1 and Non-Residential Appendices 2. They're both found in the same manual, and it can also be found on the Energy Commission's website at the link listed below. The overall training goal is to gain an understanding of the non-residential HERS verification requirements. This training is going to be broken up into 8 different sections. Sections 1 through 8 are listed here. So we're going to start off with what is non-residential, how is it different from residential, what are the HERS rater responsibilities, what is the required documentation. We'll look at sampling protocols, and then we'll get into the procedures for the actual verification and testing. We'll start with duct leakage, then we'll look at the low leakage air handler, followed by water heating systems, and last, mechanical ventilation. So what is considered non-residential? So the California Building Code has different building types. They consider them different occupancy groups, and they are lettered such as groups A, B, E, F, H, M, R, S, and U. So you might be wondering, well, what do all those mean? Well, we'll look at that here in a second. For buildings that are directly or indirectly conditioned, they must meet all the mechanical, envelope, indoor, and outdoor lighting requirements of those standards. And we're particularly going to be looking at the mechanical requirements. Buildings that are not directly or indirectly conditioned only need to meet the indoor and outdoor lighting requirements. So let's take a look at what those different occupancy groups consist of. So here we have table 1-1, and this gives us a breakdown of the differences between the non-residential standards and the residential standards. So there on the left side, we have those types of buildings that fall under the non-residential standards. And that does include some of the R groups, which, as you can see if you look over to that residential side on the right, there are certain occupancy group Rs that are considered residential. So that's the only one that covers or is included on both sides, but there's some additional distinctions that we'll look at here in a second that breaks up high-rise versus low-rise residential occupancies. So what is the difference between low-rise and high-rise residential buildings? So low-rise will be comprised of multifamily buildings that have 3 or less habitable floors and all single-family residences regardless of the number of stories. These must comply with the residential standards. High-rise residential is buildings that contain residential occupancies with 4 or more habitable floors, and they will comply with the non-residential standards. So that is the trigger there, is how many habitable floors we have. 3 or less is going to be low-rise, and that's going to be residential standards. 4 or more is going to be high-rise and will need to comply with the non-residential standards. The HERS rater will be responsible for conducting the field verification and diagnostic testing of the air distribution ducts, the water heating systems, and mechanical ventilation systems. You'll also be required for transmitting all required data describing the results to a HERS provider data registry. Also confirming the air distribution ducts conform to the design detailed on the building plans and specifications, and the mechanical certificate of compliance, which is the NRCC MEC 01. And this will be approved by the enforcement agency for the building. You also verify the information on the certificate of installation and certificate of acceptance, and that it is consistent with the certificate of compliance. So we have different sets of forms on the non-residential side versus the residential side. So all of on the residential side, we have the CF1R, CF2R, and CF3R, which is our certificate of compliance, installation, and verification. Now we have similar forms, but they're named a little bit differently on the non-residential side. So we still have certificates of installation, compliance, and verification, but we also have a certificate of acceptance. So if you look at the one that's listed here, the NRCC MEC 01, If we look at the first four letters there, NR is non-residential. This first C is for certificate of, and then the fourth letter there on this particular one, this is a certificate of compliance. So you'll see an NRCC, NRCI, NRCA, and NRCV, and those all are directly associated with installation, acceptance, verification, and of course compliance. So those forms, the NRCC, NRCI, and NRCA, those do not exist in the registry. So unlike residential, where all the forms are located in the registry, for non-residential, at this point, only the certificates of verification are going to be in the registry itself. So you have to do all of this review of the documents outside of the registry. They'll be all part of the plan set for the building, and so you'll need to get those, the certificate of compliance from that, and then the other ones from the installing contractors. The builder or subcontractor shall make available to the HERS rater a signed copy of the certificate of compliance, installation, and acceptance. Now, prior to performing field verification and diagnostic testing, the HERS rater shall confirm that the certificate of installation and certificate of acceptance has been completed as required, and the installer's diagnostic test results on all other certificate of installation and acceptance information are consistent with the certificate of compliance. So for non-residential, we do have the ability to utilize the sampling protocols. So just like on the residential side, the HERS rater will have the option to diagnostically test and field verify every system or dwelling unit, or you can utilize the group sampling method. Now, what's different here for the non-res side is the way we distinguish the type of inspection that you're doing. So if you're doing duct leakage testing, you will do every single zone space conditioning system, or SCS. If you're doing the water heating measures, it's going to be based on the dwelling unit. So because of this, you will have two separate sample groups that you'll be utilizing. So you might have a single dwelling and you're doing both a duct leakage test and verifying some water heater measures. Each of those will go into a different sample group because of the way that they're identified. So the registry will handle this. You just want to take, your 7 space conditioning systems, and they'll go into a single group. And if you're using performing water heater verification, you'll take 7 dwelling units and put those into a group. So they will be handled separately within the sample group functionality within the registry, but just be aware that they are handled individually on the non-residential side, unlike the residential side where everything is done within the single dwelling. When sampling for non-residential, we're going to be using what is called a closed sample group. Now you may recall a closed sample group consists of up to 7 either systems or dwellings. Again, on the non-residential side, we break these up a little bit differently. It's not simply by dwellings. It is going to be, you'll have your space conditioning systems that are going to be grouped together, and then you're going to have your dwellings that are going to be grouped together. So depending on what inspections you're performing will determine how you put these sample groups together. But again, you're going to be doing either 7 systems or 7 dwellings, or a combination thereof. You may have 7 dwellings, but you may have 12 space conditioning systems. So you're going to need to create 2 sample groups for the space conditioning systems, and then 1 sample group for your dwellings. So you'll end up with a total of 3 sample groups, but your testing is still going to be at that 1 in 7 rate for each of the measures. So space conditioning system measures are going to be duct leakage and low leakage air handler. So those will be in one set of groups. And then for your dwelling, it's going to be your water heating distribution measures, as well as mechanical ventilation. But again, you're still going to remain at that 1 in 7 sampling rate. It's just a little bit differently. Now, if that space conditioning system or dwelling passes, then the whole group is assumed to pass. They assume that the contractor's already tested them, states that they're passing. You're just verifying that they are passing. So If one of them randomly selected passes, then the other one should also pass. If it cannot meet the sampling requirements, then the HERS rater will have to test 100% of the space conditioning systems or dwellings in the sample group. So same rules that we see on the residential side. So for new construction only, we do have a initial test. This initial test is essentially the same as the model test that we see in the residential requirements. The HERS rater is required to diagnostically test and field verify either the first single zone space conditioning equipment unit of each newly constructed building or the first dwelling of each newly constructed building. Again, whether you're doing duct leakage testing or water heating measures. This initial test allows the builder to identify and correct any potential duct installation and sealing flaws or practices before other units are installed. Now, after that initial test is completed, the builder or the HERS rater will identify a group of up to 7 individual space conditioning systems or dwellings. And these will all come from the same building from which the sample will be selected. So you can't take 2 buildings. It might have 2 buildings in the same project, but sampling has to stay within that building. The group will be closed prior to the selection of the sample that will be field verified and diagnostically tested. So we're going to be doing closed groups only. There is no open sample groups allowed. And then the systems or dwellings in the designated group shall be located within the same enforcement agency jurisdiction and have the same installing contractor or subcontractor. So just to recap on this, it's just like residential closed sample groups, up to 7 groups. The group has to be closed before you perform any of your testing, and they have to be located within the same enforcement agency and have the same installing contractor or subcontractor. Now for altered buildings, it's going to be a little bit different. Those systems or dwellings in the designated group do not have to be located within the same enforcement agency jurisdiction. However, the enforcement agency may require that a separate system from the sample group that is located within their jurisdiction be tested. Now they do need to have the same installing contractor or subcontractor, and then the installer can request that you create groups smaller than 7 systems. So what happens if the installing contractors change mid-project? If the contractor changes, the builder must notify the rater, and all sampling of the features the former subcontractor was responsible for must be closed. So any existing sample groups have to be closed off, and no additional units from the new contractor can be added to those existing sample groups. Any remaining systems completed by the former subcontractor are either individually tested or placed into a new sample group. And then any systems or dwellings that are completed by the new subcontractor shall be individually tested or included in a new sample group. What do we do if we have a failure? So you are supposed to report all failures within the registry. The registry is able to collect those. It will create a revision for the input of additional test results. So after you enter your failure, you'll be able to then add in either additional failures or the final passing results. So if the selected SCS or dwelling fails, the contractor will need to perform corrective action to remedy that failure, and then you will need to retest that system or dwelling to ensure it does comply. In addition to retesting that initial failure, a second space conditioning system or dwelling in the group will be randomly selected for resampling. If this second sample passes, then the group will be deemed in compliance and the documents will be made available for the remaining sites in the group. If the second sample fails, then all remaining space conditioning systems or dwellings in the group will be tested to ensure the group complies. So you have to do 100% testing at that point. Documents will not be issued until that space conditioning system or dwelling passes the test. So if you're unsure of these rules are all built into the registry. At any time, if you enter a failure, the system will automatically require you to randomly select an additional site or system for retesting. And if you have two failures, then it will then require you to perform 100% testing on all of those sites that were in that sample group. When a single zone constant volume space conditioning system serving less than 5,000 square feet of floor area and having more than 25% of the system duct surface area located in unconditioned space, duct sealing is prescriptively required by section 140.4L for newly constructed buildings and by section 141.0 B 2 C, D, and E for HVAC alterations. So let's take a little bit closer look at what that means. So let's break down those three criteria. So the first one here is for a duct system that provides conditioned air to an occupiable space for a constant volume, single zone space conditioning system. So what is a constant volume, single zone space conditioning system? So constant volume means that the system has a fan that runs at a constant speed. Now this does not mean that it only has a single speed. It can still have, high, medium, low, but it's not going to be variable based on the load. So it's going to be one speed at a time. It can't go, low, medium, high. It's going to have those two or three set speeds. So single zone, what does that mean? So a zone is a space or group of spaces within a building with sufficiently similar comfort conditioning requirements. So a heating or cooling of that zone will be controlled by a single device, most likely a thermostat, and those zones are all going to be single. So we oftentimes see this on the residential side where you'll have the upstairs and downstairs of a home be in different zones because the way the stack effect works and heat rising upstairs, you have different comfort needs. So it's the same thing in a non-residential building, more where you have a warehouse space connected to office space. So if you have a single system that is serving those two zones that are somewhat different, then that would not be a single zone. So we're looking at just the office space or just the warehouse space. Those would be single zones. The space conditioning system serves less than 5,000 square feet of conditioned floor area. So that one's pretty simple. How many square feet is it? And it's got to be conditioned floor area. It's not going to be indirectly conditioned. It's going to be that which is defined as conditioned floor area. And then finally, the combined surface area of the ducts located in the following spaces is more than 25% of the total surface area of the entire duct system. So these spaces here are going to be unconditioned space. So outdoors obviously is not part of the conditioned space. Second one is in a space directly under a roof that has a U factor greater than the U factor of the ceiling, or if the roof does not meet the requirements of section 140.3A1B, or it has fixed vents or openings to the outside or unconditioned spaces. So what this means is, they want you to identify where is the thermal barrier, where is the insulation at. So if the ducts are on the unconditioned side of that thermal barrier or insulation, then that's going to be in a space directly under a roof that meets this requirement, and therefore then it goes towards that 25%. And then the last two in an unconditioned crawl space or in other unconditioned spaces. So they want to know how much of this duct is going to be an unconditioned space, which means that it's going to have a greater delta T between the air going inside the duct and the air surrounding it, which just relates to how much of that heat energy is going to pass through that duct insulation. So you hear me talking a lot about conditioned, unconditioned space, indirectly conditioned space. So what is the difference? And as I mentioned, it's really where is that thermal envelope? Where is that thermal barrier at? And is the duct going to be on the conditioned space side of it or on the unconditioned space side? So let's look at this example here. So a plenum space below an insulated roof and above an uninsulated ceiling is an indirectly conditioned space. And the reasoning for this is there's less thermal resistance to the directly conditioned space below than to the ambient air outside. So in comparison, an attic below an uninsulated roof having insulation on the attic floor is an unconditioned space because there is less thermal resistance to the outside than across the insulated ceiling to the conditioned space below. So again, this is looking at that thermal envelope, that thermal barrier, where the insulation is at and which side is the space on. Is it on the side where the conditioned air is being delivered, or is it on the other side to where it's closer to the outside space? And so we also need to be able to determine the percentage of ducts in those unconditioned spaces. So if we remember back, our target was more than 25%, and it's of the duct surface area. So how do we determine that duct surface area? We first need to measure the length of the duct and then collect the circumference of the duct. And this is all the ducts that are located in unconditioned space. And so to find that surface area, we're going to take the length of the duct, multiply that by the circumference, and that will give us the area. So they want to know how much of that area is exposed to that unconditioned space. We'll then divide the area outside the conditioned space by the total area to find the percentage. If that percentage is more than 25%, then it meets that requirement for duct leakage testing. So example, we have a duct system where the total duct surface area is 1,000. The duct surface area outside of the conditioned space is 300. And so we're going to take 300, divide it by 1,000, and that's going to give us 0.3. We're going to then multiply that by 100 to convert it into a percentage. And so 0.3 times 100 is going to be 30%. 30% is more than 25%, so that means that this meets that requirement of having more than 25% in unconditioned space, and it will require duct leakage testing. Okay, so now let's take a look at the required documentation that you need to have before you perform your duct leakage test. We touched on this briefly a little bit earlier, so now let's look at the specific documents that you'll need for duct leakage testing. So the first one that you're going to need is the Certificate of Compliance, the NRCC MEC 01E. This is the equivalent to the CF1R in the residential standards. This is the design document, and specifically on this document where you're going to be looking there is in section B. The test description, you can see it's highlighted there in the red box, and this is for the MEC 04A, and this basically, if that box is checked off, then that indicates that a duct leakage test is required for this particular system. So the next one is the Certificate of Installation, the NRCI MEC 01E. This would be equivalent to a CF2R in the residential standards, and so this does the same thing. This is a certificate of installation. This gives you basic information about what was actually installed on the project. And what goes along with that, and this is new for or different for the non-residential side, this is what we call the Certificate of Acceptance. This is the NRCA MEC 04A. And this would be most closely related to the CF2R. So what they've done here is they've taken the certificate of installation and they've separated that from the test results that we see on the CF2Rs on the residential side. So they've taken the installation and the testing and separated them into two separate documents on the non-res side. So we have the certificate of installation, and then we have the certificate of acceptance. And the certificate of acceptance is where the results of the contractor's duct leakage test are documented. So you can see on here, the form here, it's got that information on there, duct leakage diagnostic test for new duct system or altered space conditioning system, what have you. This is all going to be those test results. So you can see what method they used and what their actual results were before you go out and perform your test. And then last, we have the certificate of verification, the NRCV MECO 4A. This is the equivalent of the CF3R for the residential standards. And this is going to be the only document that is going to be produced by the registry. So unlike the residential side, where the 1Rs, the 2Rs, and the 3Rs are all generated from the registry, non-res has not gone that far yet. So the certificate of compliance, installation, and acceptance testing, those are all going to be handwritten forms. They're not going to have registration numbers. They're going to be like the way we used to do it on the non-res side. I mean, sorry, on the residential side. So you need to collect those other documents, and then when you do your test, you're going to go into the registry, create that site, that dwelling, that system in the registry, and then input your data for the duct leakage test, and then the registry will produce this NRCV MECO 4A that you can then give back to the contractor or the builder, so they can have that for the local building official. Now let's look at some of the typical space conditioning system types that you'll see in these non-residential buildings. So ducted systems will typically be attached to one of the following types, either a package or a split AC. Now these are both similar types that you'll see on the residential side, but let's talk a little bit about what each of those are. So a package system will have the furnace, evaporative coil, condensing coil, and compressor all contained in a single unit, and these will typically be located on the roof. For a split AC, the air handler and evaporative coil are separate from the condensing coil and compressor. So you have two separate pieces of equipment. Usually the air handler and evaporative coil will be located inside the dwelling or in the attic space, where the condensing coil and compressor will be located either outside on the ground or sometimes located up on the roof, depending on the type of structure. But that's the main difference between those two, and that's primarily what you're going to see. And both of these system types will usually be 20 tons or less, and will have a dedicated fixed outdoor air supply. So 20 tons, that's significantly more than what you would see in standard residential. Those usually don't go above 5 tons. So you may see larger systems, but you'll still be similar in types. Now the testing criteria for these duct systems falls into one of three categories, and these categories are essentially the same as what we see on the residential side. It's just that the leakage criteria is a little bit different on the non-residential side. So these duct systems will fall into one of three categories. Either be a sealed and tested new duct system, and this can be either for new construction or an alteration where an entirely new duct system is installed. Sealed and tested altered existing duct systems, and then sealed and tested altered duct systems that do not comply with the standard leakage. So this is where the smoke test method comes into play. So let's take a look at each of these in a little more detail in the next couple of slides. So for those new duct systems, and this is primarily for new construction, the leakage rate will not exceed 6% of the nominal air handler airflow rate. So for the 2016 standards, for residential, that value dropped from 6% to 5%, whereas the non-res side has stayed at 6% of the nominal air handler airflow rate. Now for altered duct systems, an altered system can fall into one of two categories. So it'll either be an entirely new or complete replacement duct system, or an altered duct system. Now if you're not sure what categories these fall under, what types of HVAC requirements are based on, what type of alteration it is. Energy Code ACE does have a trigger sheet. You can see there in the at the bottom there, energycodeace.com. They work closely with the California Energy Commission and have a lot of good resource materials there. So be sure to check out Energy Code ACE and see what they have available for you. So that first category, the entirely new or complete replacement duct system, so that's going to be the same as what we saw for the new construction, a new duct system. It shall not exceed 6% of the nominal air handler airflow rate. So what is an entirely new or complete replacement duct system? So that will be 75% new duct material. So this includes the actual duct work itself, any Ys, any register boots, any of the materials that make up that duct system. At least 75% of it has to be new. And then that remaining 25% of the old system may consist of reused parts from the building's existing duct system. If those reused parts are accessible and can be sealed to prevent leakage. So that's the key there. As long as it's accessible so that the installation contractor can get back in there, they can seal it up, then it's going to be deemed a entirely new or complete replacement duct system, and it will have to test at 6% or less. Now if that duct system has any part of it, doesn't matter how much, any part of that duct system is inaccessible, so it is not replaced, it's the old duct system left in place, you can't access it, so you can't seal it, then it's going to fall under the existing duct system. So when extending an existing duct system, replacing an air handler, outdoor condensing unit of a split system or heat pump, cooling or heating coil, the system will need to meet one of the following requirements. So those are the things that will trigger this altered duct system test requirement. Extending a duct system, replacing air handler, outdoor condensing unit of a split system or heat pump, cooling or heating coil, all of those will need to leak no more than 15% of the nominal air handler airflow rate. So now if you can't hit that 15% because some of that system is inaccessible, it can't be sealed, then you can fall back on the what we call the smoke test. So visual inspection and a smoke test. So now we do have a couple of exemptions, just like we did on the residential side. So an exemption to duct testing on an altered system is if the previously listed duct system has been documented to have been previously sealed and confirmed through field verification diagnostic testing. Well, how do we know that? What does this documented mean? It means that you're going to have a NRCV MEC 04. So the form that comes out of the registry means a HERS rater has been out there previously, they tested it, and it is been shown as sealed and passing. The second one there is if that existing duct system is constructed, insulated, or sealed with asbestos. There's just a check mark on the thing claiming this exemption, and then you do not need to verify that system. Now we touched briefly on the smoke test. Now smoke test, we're going to go over that in detail, or we've already gone over that. We covered those in the duct leakage section of the training. So if you don't recall what the smoke test was, go back to that duct leakage section and you can review that, and we cover the smoke test there. For non-residential, you have to be careful when conducting your smoke test if it has an active fire alarm system. You don't see these on the residential side, but on a non-residential, you're going to have these integrated fire alarm systems, and the smoke or theatrical fog can trigger that alarm system, and that means the fire department's going to come out, and it's going to be a big to-do. The active fire, if you want to prevent that from happening, the active fire alarm system must be placed in test mode prior to conducting your duct leakage smoke test. So get with the job site superintendent, make sure that they know that you need to do this smoke test and that it may affect the smoke alarm. Get them to put it into test mode, do your smoke test, and then make sure that they return it to normal operating normal operation after you're complete. But yeah, save yourself a lot of hassle. Get that thing into test mode before you do any kind of smoke testing. And as I briefly mentioned on that smoke test, not only do we cover the smoke test requirements, but all of the equipment specifications and procedures for performing duct leakage testing are covered in the duct leakage module. So if you need a refresher on that, you can always go back to that and review those duct leakage requirements in that module. An additional performance compliance credit is available for verified low leakage ducts if a qualified low leakage air handling unit is installed. Now, because this is a performance credit, it will only be indicated on the NRCC PRF 01 form, which is the performance form, and it will not be seen on any prescriptive compliance forms. The leakage target will remain the same at 6%. Unless it's otherwise stated on the NRCC PRF 01. So the compliance analyst that models this can select a value less than 6%. So be sure that you look at the PRF 01 to verify what the target leakage rate is if this credit is taken. Now, to qualify for this credit, the air handler that is installed must meet specific criteria, and it has to be submitted to the CEC for approval. Now, approved equipment will be placed on the list, and this list is maintained by the CEC and is available on the CEC's website. And so we provide the link here where that list is stored on the CEC's website. Now, as the HERS rater, your responsibility is to collect the make and model number of the installed air handler and check it against the list of approved equipment. So you're going to open up that list and verify that the equipment that was installed is on that list. And if that equipment is on the list, then it passes and you're done. You just move forward with your duct leakage testing. If the equipment is not on the list, then you need to indicate it as a failure, and this will be done in Section C of the NRCV MEC 04, and note that it is not on the approved list. Now this will give the feedback to the installing contractor that the equipment is not on the approved list and that they either need to change it out for an approved piece of equipment or they'll have to rerun the energy calculations without that low leakage air handler credit. Domestic hot water, or DHW, distribution systems will need to be verified when the NRCV PLB21H or NRCV PLB22H are indicated as required on the NRCC PRF 01E in Section M1. So we can see down below is a screenshot of Section M1, and you can see that there are several different PLB forms as well as an STH form listed there. So if either the PLB 21 or 22 has a check mark next to it, then you will need to perform the verifications associated with that. Now, as we mentioned, the NRCC PRF01 is a required form. This is what you'll be looking for to verify whether or not the water heating distribution verifications are required. So this is your certificate of compliance, very similar to the CF1R that we see on the residential side. So we also have the NRCI certificate of installation for the PLB 21 and 22. This is the equivalent to the CF2R, and the different forms depend on whether it is dwelling specific or for the whole building. So that's the difference between the 21 and the 22. And just like the other ones, we have our certificate of verification for each of the 21 and 22. So this form, just like we saw with the duct leakage, the certificate of verification comes out of the registry. The other forms, certificate of compliance and certificate of installation, those will be filled out by hand. You'll need to collect those prior to performing your inspection, and then you'll enter your test results into the registry on either the PLB 21 or 22, and then the registry will generate that registered certified document so that you can give that back to the building department or to the builder, so they have that available for the building department. The procedures for performing verifications on the following credits are outlined in the water heating systems module. So now these verifications are exactly the same as what you would do on the residential side. There's no difference other than they are in a non-residential, usually it's going to be a multifamily high-rise type scenario where you're used to seeing a low-rise multifamily. So we're going to cover where these sections are covered on the forms themselves, just so you have a point of reference for that. So the HERS verified multiple recirculation loops for DHW systems serving multiple dwelling unit requirements. So this is going to be on the PLB 21 in section H. The HERS verified compact hot water distribution expanded credit is going to be on the PLB 22 section G. The HERS verified drain water heat recovery system is on the PLB 22H. Pipe insulation credit is the PLB 22 section J. Central parallel piping is a PLB 22 section K. Demand recirculation with a manual control is the PLB 22 section L. And last is the demand recirc sensor control on the PLB 22 section M. Again, all of these are covered in detail in the residential training, which you've already taken. So if you need to, you can go back to that section, either in the training system itself or on the YouTube channel. We have them all listed there. You can go back and review those to get a refresher on how to perform those verifications. Mechanical ventilation systems. So the purpose of this diagnostic test is to measure the airflow in mechanical ventilation systems to confirm compliance with the requirements of ASHRAE 62.2. These procedures are applicable to continuous and intermittent mechanical ventilation systems in high-rise residential dwelling units. So there are several documents that are going to be required for the mechanical ventilation verification. So we're going to start off with either the NRCC MEC form or the NRCC PRF01 if it is a performance compliance option. So those are going to be your certificates of compliance, and those will be your first indication as to whether or not mechanical ventilation is required for this project. Next, we have the NRCI MEC 01. This is the certificate of installation. This is where they're going to document the equipment and the design, what was installed out at the project for your review. And then last, we have 3 NRCV forms. So we have the MEC 24, the MEC 27, and the MEC 32. These are the certificates of verification. These are the documents that are going to be registered. So you're going to get them out of the registry itself. And so you have the MEC 27 is just like on the residential side. That is the mechanical ventilation form. The MEC 24 is when the blower door is required, which these are attached units because it's multifamily high-rise. So they're all going to be attached. So you are going to be doing blower door testing in conjunction with the verification of the fan flow. So you're going to have the MEC 24 for the blower door, the MEC 27 for the mechanical ventilation, and then the MEC 32 is your kitchen exhaust verification. So again, just like we see on the residential side for those attached units, we're going to be doing those same verifications and documenting those in the registry for the high-rise residential units. The equipment specifications and procedures for performing mechanical ventilation testing are covered in the mechanical ventilation module. As I just mentioned, it's exactly the same as what we do on the residential side. So you've already been trained on this. All that's been covered in the new Raider training. So if you need a refresher on it, you can go back to either the new Raider training module, or you can go into visit the YouTube channel where we have all these training videos listed, so that you can go back and review that for this verification. Should you have any additional questions or comments, as always, please feel free to reach out to us through the LMS system or directly by email or phone call to the main office.